Alright, you guys, so let's go ahead and get started here. We are going to be working on the explicit formula in arithmetic sequences. In this case, once again, arithmetic sequences are sequences in this case where you're either adding or subtracting to get from one number to the next. So if we take a look at the example here in the warm-up, arithmetic sequence once again is how do we go from 13 to 6 to -1 to -8 and so on. So that's what we're going to go ahead and be doing. We want to go ahead and convert from recursive. This here is a recursive form onto doing an explicit formula. And that's basically a formula that's going to be defined by the sequence here. So in this case, guys, explicit formula, it's a formula for any term depending on the given terms we're given. So once again, based on the sequences we're given, we're going to be able to create an explicit formula here. So in this case, guys, starting off, once again, recursive. This is just something we saw in the previous lesson. A1 in this case represents the first term. Whatever sequence we're given, the first term of that sequence does represent A1. And in this case, common difference is how we're going from the first term to the second to the third and so on. In the explicit form, guys, we once again need the first term, we need the common difference. The only thing different here whenever we're writing the explicit form is that the common difference here is going to be multiplied by n-1, and this is all the time. So let's get started here. So in this case, guys, we are going to given in this case the sequence of a 3, 5, 7, 9. It says below is an explicit formula for the sequence, and we're actually going to go ahead and write the explicit formula. So once again, I want our first term, which is A1, and then we're going to go ahead and identify the common difference here, which in this case, we'll see how do we go from one term to the next. So starting off in this case, guys, first term is the first number of the sequence. Our first term here would be a 3. And a common difference in this case talks about how we're going from 3 to 5, from 5 to 7, 7 to 9, and so on. So in this case, guys, how do we go from 3 to 5, 5 to 7? We're actually adding 2 each time we move. We're adding 2. So in this case, our common difference here, guys, will be +2. So this is how much we're adding each time. All right. Now, based on this here, guys, I will be writing my formula. So the explicit formula, we'll be writing it in red. So we'll go ahead and do A of n equals my first term, which is 3, plus the common difference, plus or minus the common difference. In this case, it's a plus, and -1. And this here, guys, represents the explicit formula. That's not what we want to, well, that's part of what we did. Explicit formula, that's the first thing. But we want to go ahead and find the fifth term using our formula. Once again, just by looking at this here, I know my fifth term is going to be 11. But if I use the formula here, let's just verify that it is correct. So if I do A of 5, once again, in this case, n is going to equal 5. So wherever we see the n in the formula, that's where we substitute the 5 plus 2, 5 minus 1. This becomes 3 plus 2 times 4. So then 3 plus 2 times 4 is 8, is 11, which in this case was our answer there. So that's just to show you that it does work when you have an explicit formula. So for you guys, I'll let you find A of 10 and see if you could find that number. All right, so that one's for you guys to do. Now let's go ahead and take a look over here, which is writing explicit formulas. All right, so in this case, guys, once again, it says find the explicit formula for the arithmetic sequence. We have -5, 13, 31, and 49. So whenever we're writing explicit formula, guys, we do want to go ahead and identify our initial term and the common difference. In this case, guys, initial term is our first term in the sequence. First term in the sequence here is a -5. So I'll just write this down again. A of n equals -5. Now, how are we going from -5 to 13 to 31? And in this case, I want to say we're basically adding 18 each time. And let's just double check. One way for you guys to check, guys, is actually subtract the first term. I mean the second term from the first. So I would do 13 minus a -5, which would give me 18. Or I could do 31 minus the 13, 18. Or 49 minus 31, 18. So that's how you can find your common difference there. So we're actually adding 18 each time, adding 18, and so on. So in this case, I'm going to go ahead and do plus 18 and minus 1. And this would be an explicit formula. All right. Now, this isn't the only way you can write the explicit formula. This is actually way number 1. So if I want to write way number 2, all I have to do in this case is actually distribute that 18. So I have a to the n equals -5 plus 18n minus 18. Combine your like terms in this case, and you would have 18n minus 23. And that could also be an explicit form. So either of these two is the exact same thing. Once again, only thing different is I went ahead and I distributed the 18 on this second one.